Hello, I'm with Emily Bash, and today we're gonna work on Kata that Emily's worked on. This is called the leaf kata, and Emily, maybe you could say a bit about yourself and a bit about this kata that we're trying to solve today.
Hi, it's great to be here. Thank you for inviting me. So I'm a technical agile coach. I work for ProAgile, which is a consultancy company based in Gothenburg, Sweden. And I really like little exercises and teaching and learning test-driven development. So you might have tried the Gilded Rose Kata. That's one of the most popular ones on my GitHub page. But today we're going to work on a different kata, which I've been putting together lately. It's called the Lift Kata. And it's in a way similar to the Gilded Rose in that I want you to try doing it with an approval testing approach. At least today we're going to try it with an approval testing approach.
Yeah, I've never done it, so for me it's a first. I try to do these things in Premiere, so let's see how things work.
Yeah, so approval testing is often used for legacy situations like Gilded Rose. But here we'll be building up new code and seeing how it differs from a standard TDD approach, hopefully. So do you want to put the GitHub page up on the screen?
So now you can see the GitHub page. I cloned it here. This is from me, but if you want to go on Emily's page, you'll find it here.
So this lift kata, I've got a starting position for it. So usually when you do a kata for new code, you start from scratch in your editor. But I'm decided that it would be useful to have a starting position for the approval testing approach, because one of the first things you need to do is to write a printer. And that's code that people maybe aren't so familiar with creating these kind of printers. So I thought, well, I'll just put a starting position up with the basic lift entities and a way to print them. And then it's a good starting position for doing the approval testing approach. So I've translated it into C#, Java, and Python so far, and other languages are welcome if you want to send me a pull request. And so if you scroll down, there's a description of the exercise a little bit. So as it says here, you've got a printer and enough of the implementation of the production code to have something to print. And then there's a little picture here of what it looks like. So when you print out a lift system, it could look like this. This system has got 4 lifts, A, B, C, and D. There are 4 floors, 0, 1, 2, 3. And you can see that lift A is on the 3rd floor and B is on the 2nd floor. C is also on the 2nd floor, but it's got its doors open. That's why it looks a bit different. And on the 1st floor, there's a down arrow showing that somebody's standing on the 1st floor and has pressed the down arrow. And then you can see on floor 0 there, you've got lift D, and there's a couple of stars. So lift A is got a request for the floor 0. So somebody is standing in lift A and has pressed floor 0. And so I've chosen to actually mark that on floor 0 rather than next to A. For lift D, it's also got somebody who's pressed on floor 0. And since the lift is standing on floor 0, that request is presumably about to be fulfilled because D just needs to open the doors. And then that request will be fulfilled.
Okay.
So that's what we've got so far, basically. We've got enough code to print out the state of the lift system. And I've introduced the concept lifts have doors, they have a floor, they have requests. And the lift system as a whole can have several lifts and calls from particular floors. So that's what you've got to start with. So if you scroll down a little, it goes to the description of the actual exercise, what you're trying to build. And you basically want to build code that's going to simulate a lift system. And everyone's been on a lift. You know how they work, basically. But here you've got to code that to make sure that the lift moves to the right floor. So it just explains here, lifts move between floors. You've got some buttons inside the lift that passengers press. There are calls. People can stand on a different floor and call the lift. And the lift has doors, which can be open or closed. And then some parts that haven't been implemented yet. These lifts that in the starting code, they don't move. So that's the part you need to write, at least at first.
So, where's that one? In the code, in the texture?
So I'm just saying there's a line that says in the repository that much is already implemented, and the following features are not yet implemented.
All right, so this one.
Yeah. So this is the part that we need to think about. So we need to get lifts to fulfill requests and fulfill calls and make sure that it doesn't move with its doors open, things like that.
Mm-hmm.
So this is a real-time system, and in a real lift real-time system, you'd have kind of an event loop that would go around really fast. But just to keep things a bit simple, we'll have a tick method, and when you call it, the system will move to the next state. And I'm assuming that that tick is long enough for the lift to move to any other floor or to open its doors, basically.
Okay.
So that's what you've got. So, and then it goes on to explain, well, when you've got the basic lift features working with one lift, you should get some more lifts and make sure that the right one is going to the right floor. And then there's some more features that you can implement around monitoring what floor each lift's on and making a ding when you open the doors. And those things aren't shown in the printer at the moment, so we'll leave them for a bit.
Okay.
So that's a basic explanation of the exercise. Should we look at the code?
Yes, let's look at the code. I see 4 classes, and I think there were some tests as well, right? Yeah.
Yes. So do you want to just run the tests and check that they're all passing? See that we've got everything set up?
Yeah. Great.
Great. So you can see there are some tests there already, but they're all for the lift printer. So they're not actually testing any functionality. There isn't any functionality, but we can have a little look. We've got a lift system class that might be interesting to look at.
We have a lift system class, yes.
Right. So this is the one that's got a list of all the floors that they're going to have in the system, all the lifts, and all the calls. People standing on floors who press buttons. So I've already made some design decisions that the call belongs to the lift system. But then if you look at the lift class, so the lift class owns it's got an ID. It knows what floor it's on. It's got some requests, and it knows whether its doors are open. And that's basically all the lift stuff. Then the other 2 classes we've got here is a call class. And the call is for a particular floor and going in a particular direction. Because when you're standing on a floor, there's usually 2 buttons for up and down. So that's the direction is just up or down if you look at direction.
Yeah, and then direction is just up, down. Yeah. Okay.
So I think what do we do now? We've understood the existing code, and we've understood hopefully a bit about the problem we want to solve.
This is the printer.
Oh yeah, the printer code. I've kind of was hoping you wouldn't need to really examine the printer too closely, just kind of accept that it kind of works. But you could look at some of the output it produces, I guess. There's the approved files there.
This one.
Yeah, so that's, you've got quite a few lifts there.
Just opening up. So this is approved txt. This is from approval tests. And this will be like the golden master, how do you call it? The things that we want to compare it with and to check that we didn't mess anything in the code. So this should be our standard, right?
Yeah, for the lift printer, this is what it should look when you print out these different lift systems. So it's got some kind of examples to exercise all the functionality of the printer.
And this is no lifts. This is the simpler one, probably, where you have no lifts and floors. Just floors.
Just floors.
this is one lift, but with no doors. So you just have the requests, I guess. But the lift won't stop anywhere.
Well, you can't see the doors at least, so you don't know what the laws are. So without that, it's a bit hard to see whether you've done it right, I guess.
Yeah, of course. But you just introduced here the concept of calling it, I guess.
Yeah. So what I would do now actually is start to think about what scenarios do we actually want this lift to support, because at the moment it doesn't move. So the first requirement that we had was that lift could move and fulfill requests. So I might actually start just by sketching what I think this scenario should look like. So I've got my notepad here. I don't know if the video is good enough to show my sketch, but
we're gonna try.
Okay, so I might have a lift. So I've got a lift on my sketch pad, and then I might have a request for the third floor.
I might can keep it a bit on your left, I guess. Yes.
Or should I put it closer to the camera?
Yeah, that's great. Yeah.
Now you can see it.
Yeah.
So that would be the initial position, and then I would want to call tick to make time move, and then I want the position to move so that the lift goes to the third floor where the request was. So that would be I'd draw it if I wasn't worrying too much about the doors, but we could do doors if we wanted. So then if we included the doors, it would look like that to start with, the lifts with closed doors, and then it would move up to the third floor with the doors closed, and that would be the next step. Now you see the 3 steps in this scenario, I think, and that's basically one scenario, really. That's a scenario for the behavior of the lift system.
For moving it.
Yeah. So I might start there, and then I might think, well, there's obviously a load more scenarios that I can think of, like answering calls and when I've got more than one lift and all that. But I thought maybe we could just start by implementing that one.
Yeah, sure. So for that one, you want to use approval tests, right?
Right.
So we need to add something here. We'll just add it here, right?
So there's a lift system test there that you should have a look at.
Okay.
So this is it's got a nice to-do comment there saying that this is the
all right.
We can start here.
So if I do this,
with pressing the green arrow in the gutter should run the test.
All right.
There we are.
That's great.
Way!
We made it red, so that's good.
Yes.
Okay.
That's progress. But before you close the Project Explorer, I need to explain about approval testing. Because you see, it's created a file. It's created this. It's named lift system test.do something, which is the name of our test case. .received.txt. This is what the printer has produced for this test, basically, which isn't quite like our sketch. Let's read the code for the test as well. I don't think we did that either. So the do something test here.
So we have a lift at the ground floor. We have, okay, and then the lift stick. So it's that verification of all the calls, right? And then it should print the lifts in the current situation. It doesn't have any floors, right? Or it has one floor. I don't know why it has one floor.
Right. So if you go back and look at the first argument to the lift system constructor, I don't know why it's not printed any little helpful things, because the lift system, the constructor on the next line,
Where? What do you mean?
The next line, the lift system.
Yes.
So the constructor call there, we're calling new lift system, and that takes 3 arguments, and it's not prompting you with
It's
a little
floors, lifts, and calls. Yeah.
Yeah, it's not, because usually it has these little
like here
they're called, yeah.
with ID and lifts, but the lift system is in the same place, in the same. I don't know.
Yeah, IntelliJ is not being helpful here.
Exactly.
But anyway, the first argument there is the list of floors that you've got. So you've got floor 0 and floor 1.
Okay.
And then the next argument is the lift. So you've got the lift A. And then the third argument is any calls, and there aren't any calls, so I'm passing it an empty list.
Okay. Yeah, that's what I mean. So these are the floors. This is why it's 1, 2. So if I would do something like, what happens is
it's thinking.
Yes. And in the
Test failed again. Yep.
Now I have the second floor as well.
Right. So now we've understood a little more about how this system thing works. So this is looking better. This is looking a little bit more like our sketch. There's a couple of things. I would like to rename the test.
Yeah, of course.
Do something is not really.
Yeah.
So we should name it after the scenario we're trying to implement.
So we want to move a lift.
We want to answer a request. Or fulfill a request, even. Get this to match our sketch. We're going to need another floor as well. I want to have 3 floors here.
Yeah.
This is my sketch.
So let's add the third floor.
Yeah. And the other thing about the sketch is I've actually got 3 situations. And at the moment, we're just going to print out the last situation. We're only calling tick once, in fact, anyway. So the other thing I might want to do, actually, is to actually collect up a string of all 3 positions before I do the verify. Because with approval testing, you only do verify once at the end of the test, and you pass it a string, which you want to check against the approved file. So can we just extract a variable for all of the stuff that's in the verify at the moment? So we could just name the new variable to verify or something like that.
Okay.
Right. And then we can actually initialize that before we call tick. So we move it up a line. Yeah, and then after tick, if we append to it the new, so
that's a string, right?
Yeah, so you just do a plus equals, I think. This is Java. And then we want to print the lift system again.
So how do you take that?
So we need this lift system
print
printer.
Again.
Yeah, so if you extract
so
a variable...
need to do this again, right?
Yeah.
So it would be this, basically.
Yeah.
So now I could re-extract a variable from this.
I would extract a variable for the printer, so we don't need to construct a new one every time.
The printer, yeah.
Yeah. Yeah, like that. Yep.
Because this doesn't hold state, right?
No, it doesn't hold any state. No. And then the other thing is, I think I might just want to print out like a new line or something in between. Actually, we could just run this and see what it looks like. So there, it's produced.
It's
do
parsing,
something.
it's doing, it's resolving dependencies, downloading the internet. Yeah.
So when you change the name of the test case, of course, it changes the name of the file it's looking at.
So I need to delete that, right?
Yeah, delete that one.
Great.
But so you can see here it's printed out twice. But it'd be nice if there was like a blank line or something in between, so we can see clearly the It's there, it's before and after, or it's, you know. So if you just, after the tick, if you do to verify plus equals a couple of new lines. There we are. So now we can have a look at it again. Well, that looks a bit, yeah. So now it's a clearer that they're, you know, but the lift hasn't moved.
Exactly.
Oh, and we haven't got the request on there yet either. So this is looking better. It might be, it's not looking quite like my sketch now, but we're getting somewhere. I might be inclined to actually approve this now, because once you've approved it, your test passes, and then you can refactor if you want to refactor.
But so if our test says fulfill request, is it that we fulfill the request because nothing did happen? No,
we're not done yet. We're not done yet. But with approval testing, you want to. I'm working from a sketch, and the test isn't finished until the output matches the sketch. But anytime I want to do any refactoring, I can just approve the results, and then got a passing test that represents where I'm at the moment. So I might be approving the output several times before I'm finally satisfied with it.
Okay.
And it's better than it was. So let's have a baseline that's something.
So what do I do that? How do I approve it?
So what you do is you rename the file. So it's called .receive.txt. So if you just write, there's a rename command, refactor rename. It's like
so it's the usual
Shift F6, yeah.
Okay, because it's a file, yeah.
And then just replace received with approved, and accept that. So now if you run the test again, it will actually pass. Because it will whatever gets past, what gets past the verify method will get compared with the approved file. So it's green.
Yeah.
So that's I feel like we're making progress here. It looks a bit more like the sketch, but we're not done yet. From
the point of view of source control, would you commit it now or later?
Probably not. No, because I'm not done yet.
So you just commit it when you're done.
Yeah, and I know that IntelliJ has a local history as well, so I can get back to any point and see whether the tests are passing. So, so I probably wouldn't commit yet. But anyway, so just to review can you open the approved file and we can just review where is it not matching our sketch yet?
We have only one. There you had 3 stages, right?
Yeah. So we could add the 3rd stage as well. Yeah. But we could. I might intend to put the request on actually.
Okay.
So that's what we're trying to do. So we want to add a request to the lift for floor 3.
And that's how do you do that?
So is there a method on lift A for that? No. It might have a constructor argument that is requests.
So is it this one now?
Yeah, if you do Alt P, you can see all the I think you have to put, and it's not Alt P, sorry, because that exits the presentation mode. No, but if you put the cursor inside the brackets for the argument list of the constructor, there should be some quick docs that you can get to, or I usually, is it Command P? I don't know. Can't find the declaration to go
Control P,
So there we are. Control P. There we are. So you can see it's overloaded with several constructors.
So you have the floor, the requests, and doors open. Okay.
Yeah. So we could pass some requests here.
Floor. Okay. So here to have the requests are a list of integers. So it would be something like this.
I think you need to put them as a 3rd argument rather than the 2nd argument.
Wasn't it I think it was 2nd. So it was floor, requests,
ID
and
first.
doors open. Yeah.
So this ID is A, the floor is 0, and then the requests.
Okay.
Yeah.
Nope.
It should be a list of integers. That was one of the options it gave you. Yeah.
Yeah, but that's what I'm saying. If you look at the definition, it's the floor. So it's the ID, then it's the floor. Then the third would be
the requests,
and then the doors open. Okay. Something like that, right?
Yeah.
Okay. And that should be... How do I do that?
So you want a list that contains the number 3.
So it's just... it's a list, okay.
But this is Java, so you do collections.singleton list.
Oh, collections.singleton list. That's how we want to do it. Okay.
So list literals in Java are not quite as advanced as other languages, I think.
Yeah.
But
this is 3. This is how I do it.
Yeah.
Okay. And now lifts is upset.
Yeah, so you just got to, if you remove line 22.
Oh, yeah, of course. All right.
So let's try running this and see what it looks like.
I've done too many languages in the past year. I'm getting confused. So this is the received, where I see the request.
Yeah. So now you've got a received and an approved file. If you highlight both of them at the same time, so with like a shift to get both of them, it's Control D, I think, to compare them. So you get a nice diff, and you can see what you changed.
Yeah.
So we can clearly see that the request is now being printed. So you can. So I would approve this. So use the little arrows to move the.
Oh, okay. So again, and I do this, right?
Yeah. So okay. So far we've made progress. It's looking a little more like the sketch, but
So now if I look at this, the approved is the same as the received. Yeah.
Yeah. Yeah. So it's nice to use the diff tool to do the approval, because you can see exactly what it is you're putting into the approved file.
Yeah, that's very nice. Yeah.
Right. So I think instead of doing another tick, I think we need to get this lift to move. So I think the tick method needs to actually do something. So let's have a look at that.
Currently it's not doing anything.
Yep. So that's clearly what needs to happen, something here.
So we have floors, calls, and lifts.
Yeah. So here in the lift system as a whole needs to, yeah.
And I need to take the call. So I have just one lift. What would be the simplest thing to do? Because I don't know where it takes the how it takes the string. Is it this one? So how do you print out this? How do you print out the string with the result of the system when tick is called?
So we're doing that in the test. We've got the printer printing the lift system before and after the tick method. That's got. So in the tick method, we need to. This is a production code here. When we call tick, that means that the lift system needs to simulate time passing. So we need to probably somehow tell the lifts, time has passed, you should do your next action. So I would loop over the lifts and call tick on all of them.
Okay. In the tick?
Yeah, so the lift system has got a list of lifts, and all the lifts need to move, potentially. And I'm making a design decision here that the lift itself is responsible for doing that moving. But you can make a different design decision. So I'm thinking if I loop over the lists, I can tell each of them lift. Now it doesn't have a tick method, but we could add one. I think you need to put the type of lift on line 34 in the for loop. I mean lift.
Sorry, yeah.
Yeah, so that's the lift system is just going to delegate all the logic to the lift class.
Okay.
Yeah. So if we go to the lift tick method here.
So here, what does it do? It gets the ID, gets the floor. So we need to change something in these. Probably change the floors. That's how time passes.
Yeah. So the simplest thing to do is this dot floor equals requests dot, I don't know. So we're going to move the floor, and we know what floor to go to because it's in the requests. I think is this a list? These requests? I think it's a list.
I think it's a list of integers.
Yeah. So we should just get the first elements and go there. Go there. Get 0.
Okay.
So let's run the test. See what's
Cannot
that?
Assign.
Oh, it's final. Oh dear, that's a mistake.
Final.
It should not be final. We can change that. None of these things should be final. I think that's a mistake in the starting position. I'm going to fix that.
Yeah.
Let me make a note.
Right. And now, if we go back to the test, let's run this.
Great. So it fails. Let's have a look at the diff.
Control D. So
Wait.
Yeah, it moved there.
Yeah, it moved to the 3rd floor, and we can see that the request is still there. So actually, that looks like the sketch. The first two parts. Hey, so let's approve that. So we're making progress, but there were a number of problems here.
The request still exists. It shouldn't exist there, right? After
it should still exist. Once you open the doors,
yeah,
it still exists until you open the doors and let the people out who wanted to go there. So that's okay. But if you look back at the production code that we wrote in lift.
Yeah, sorry.
So there's definitely a bug here.
Yeah, this one.
If the request is empty, then we're gonna get an exception.
Yeah.
So we need to make a note of that. Our code doesn't quite work yet.
So would you fix it now, or would you just make a note and try to add another test to force you to fix it?
So I'm thinking I definitely want to fix this, and this seems to me kind of an urgent problem.
Okay.
So I might just at least put an if, just so this is refactoring. But no, it's not refactoring, but adding functionality. If requests is not empty, is empty, and then a not at the start.
I don't know. Brackets or not? How do you prefer it?
Yeah, you have to have brackets in Java, I think.
Not with this code.
Oh, I guess so. It has some brackets.
All right.
So I'm a little bit happy about that now.
My personal preference would be just to leave it here, maybe put a comment there, and with the next test I would add something to force me, or something like adding a lift that doesn't move and this would crash. So that would be my way.
Yep, that's absolutely. I mean, if we could easily add another test case for that, actually. So yeah, do you want to do this test driven? You could.
No, but it's fine. I mean, that's just to say that there are different options. I think everything is fine. Here you're why I'm doing that, because I want to focus on my flow of doing stuff, and this isn't in my current flow. Personally, I tend to get easier out of flow, so that's why I do that.
Yeah, I mean, there's nothing stopping us from going back to the test case and adding another one with a lift that doesn't have any requests and doesn't move. That might be a good test to have, actually.
Yeah.
Let's go back to lift system test and add that one.
So lift system test.
I should just copy this whole test case.
And we just have two lifts, right? Or just have a lift and it doesn't move?
Yeah, so if we just take the requests away, so if we just remove the last two arguments to the constructor, and we need to rename the test case. So this should be something about idle lift. Yeah, so it doesn't have any requests, and then when we do this stuff, it doesn't move. So
that's fine.
We can just run this one now, I think.
So it doesn't do anything.
So it doesn't crash because we wrote the guard clause. So let's approve that one.
I still like to do red-green.
Yeah, let's go and break the code and see it fail. Absolutely.
Sometimes surprises happen.
Yep, so you didn't get a receive file this time. So this is the slight thing that's still there hanging from last time.
Yeah.
But you can see the test has failed, but if you look at the stack trace.
Yeah, index out of bounds for length 0. It should be in lift. So yeah, exactly here.
Yep. So that's a slight thing with approval tests. It can be difficult to see whether the approval failed or whether something else failed. Because you might still have a receive file hanging around from the last test run.
Yeah. So we have this one now. We need to approve it, right?
Yeah, let's approve it.
And now run it again? Or it's just enough?
Run all the tests again, yeah. Great, we're green.
Green.
Yep, but the test we're working on, the fulfill request test, still doesn't quite look like the sketch. So we need to do some more.
Yep.
We need to actually open the doors, I think, to fulfill the request.
Because here the door is not open.
Yep.
So to fulfill the request, how do we test that? Do we want to test it first, or do you want to change the production code and then check it?
Well, at the moment, if you open the approved file for fulfill request, so if we just compare this against the sketch, the first two states are actually correct now. It's the third state is not there yet. We're not calling the tick method again. So we need to update the test, I think, to call tick again and then print the state again.
Okay, so that means we need to do something like this.
Yep.
And then do something like this.
Yep. And then you probably want to add the new lines again as well.
Yeah.
Yep. So now run it again.
And now we'll see that the third step is identical to the second one, which is wrong.
Hopefully, yeah. If you bring up the diff. Yeah, so we've got a third thing now, but the lift didn't open the doors. So that's what we need to code now. So we've got it's looking better, but it's not right yet. So now we go to the production code.
It's in the lift.
Right. So I think we might need some logic to say.
We need to affect this one. The door's open.
Yeah,
right?
The door's open. So when do we open the doors?
When we reach the floor that was requested.
So we put another if statement after this if statement. So if this dot floor is equal to request dot get 0. Let's have another null pointer exception coming up here. That'll do.
Fine,
okay, so then we should open the doors.
Do you have a method for that, or just change?
No, I mean,
okay.
Yeah, just assign it to true. Yeah. So if we're on the right floor, we open the doors. Seems a good start.
Leave test. Let's check this. Something failed. Let's compare them. So we have the doors open, but the request is still on. Is it correct?
No. So we've got a couple of problems here.
I should remove this, right?
Yeah. So we need to remove the request once we open the doors, but we can see we've opened the doors too soon.
Oh yeah, right.
So it's not quite there yet. So if we look in the production code again, we might need an else there. Because I'm thinking if on the tick method, we've got to decide what to do next. And if we've got a request, we should go there. If we're on the right floor, then we should open the doors.
Yep.
So let's try that. Oh.
What did I do wrong? Oh, yes, of course.
Else if.
It's an else if, which I hate, but we'll fix this later. Okay, so now it's failed.
Oh, that's looking a bit better. Maybe? No. Now it didn't open the doors. We're back to where we were. Can you just approve that where it got to anyway? Okay. Because it looks, we've got the third step now. I'm just thinking every time it gets better, I'm inclined to approve it, because then I can see what difference my latest code change is making.
Okay.
So that's the production code. We got something wrong here.
So we moved to the last floor.
So the first time we call tick, it should discover it's got a request, and it should move to that floor. Otherwise, if we're on the right floor, it should open the doors and remove the request. Maybe that's what we're getting wrong. So inside this if body, as well as opening the doors, no, the other if body.
Oops. Yes.
So as well as opening the doors, we should remove the request, because we've fulfilled it. So we put a new line after doors open equals true.
Yeah, I was thinking if it's before or after.
I kind of figure you have to open the doors first, and then remove this dot floor. I suspect that's going to make things better, because now the request is going to be empty the next time you call it. Maybe that's going to work.
Come on. I don't want to put breakpoints.
No.
Okay, test passed.
Yeah, but that just means we didn't change anything, because we approved it when it wasn't. I was expecting something to change there. So that didn't work. It's still not opening the doors.
Yep.
Can we move this, flip the order of the if statements? Is there a refactoring for that?
I never know.
Invert.
Not invert.
No.
No.
What did that do? Anyway, I just want to do the check on if we're on the right floor first.
Swap, I think.
Ah, that looks better.
Yeah.
Can we try that?
So now it's failed.
Oh, that's good. Oh, except it's failed for some other reason. I think we've got our unsupported operation exception. Oh dear.
Yeah, because it's the it's this.
Can you click on? So no, it's line 52 that's throwing the exception.
The remove. Oh, it's
the remove.
52. Yeah.
Yeah. So we've got a list that we can't remove stuff from. I think that's the problem. Collections.
Well, this is a list. Why?
Yeah. So we need it when we constructed it in the test. I think this dot requests when it came in from the outside from the test case. So I think we go back to the test.
This one.
It's not a singleton list. I think that gives you it must give you an immutable list. So maybe we just do this pedestrian way with new array list and then add the 3 to it. Yeah, I'm showing my ignorance of Java here.
Me too.
There might be a better way of doing that.
I'm happy to be that ignorant with collections in Java because they're just sometimes way too complicated. All right, so now index out of bounds.
Oh, now we get index out of bounds.
So now it's probably at 52 here. All right, so the same. Let me do the the blunt approach.
Yep.
I know it's not right, but at least we'll see if the logic is good and pass the collections problems. Failed approval. Okay.
Good. That's better.
Yeah, that's good.
Oh, there we go. The door's opened. Let's that matches the sketch now. I think if we approve that.
Yeah.
I think if we've got all the steps working.
Mm-hmm.
So we approve the test, so that should pass, and now we can refactor. And
so would you commit now, or would you commit after refactoring?
We could commit now, especially if I'm anticipating any problems with the refactoring.
Oh, lift cut. Okay. So I'm on master. Probably I want to make another branch. Okay. So I added those files and we changed some code. Okay. What do we say? Lifts can move.
Yeah, and fulfill the request, but we need to do some refactoring.
Request one lift can move in between floors. Okay. And yeah, of course, we need to do refactoring. So what to do? Where to start from?
Right. So
this one is obviously I think for me this is the worst.
Yes. So I'm thinking of the list of requests here. I've modeled it here with a list, but it's actually a set, I think. I don't know if we'd be any better off with a set though, because hash sets. I mean, you should be able to remove stuff from a hash set. So can we refactor that in some way? Or actually, yeah, that's a good idea. So now the test doesn't need to change. We can just on line 18, we can fill the requests with the elements in the list. There we are.
So what do you mean? I need to.
So so don't change that. On line 18.
Yes.
Can you do new hash set or some way to add all the elements of the list to the hash set?
Okay, I think you were saying.
And does it take a constructor argument for the
Add all?
All right, yeah, that would work.
No,
Well,
because it's a collection and this is a...
No, I think the problem is it's the assignment. Can you actually pass it to the constructor? Yeah, requests? Yeah, I think we can just pass requests there. Yeah.
I don't think so, but you might be right. Yeah, this works. Okay.
So that means that we now switch to a set. So when we go down, instead of assigning it to new array list, can we just do remove? We could try that.
Now it wants an object. And the object should be, I don't know.
This.floor, yeah?
It's an object. Let's see if this works.
It won't work because it's still not compiling, because you can't call get on a set.
Where is that? But where's the...
So it's not compiling on line 51 and 56?
Oh, this one I wasn't seeing.
So I think we can do request.contains self and this.floor, you know.
Yeah, and this is even better. But it still doesn't like that.
So you need to remove the this.floor double equals.
Yeah. Yeah, of course, yeah. And but now this floor.
Right. So now we know that there's actually only one element. But we could iterate over them and take the first one.
Oh, that's interesting. Remove if.
Yeah. But can you hide that just to remind us, what is it we're actually doing on this line of code? I can't remember.
We want to take the floor. No, we want to say that we are on the floor of the request.
No, yeah. So we want to move to the floor that's in the requests, and there could be more than one floor in there. So we would like some logic here to find the best floor to go to, because there could. But that's the next test actually. So we just need a way to get stuff out of the hash set. Is there a?
No.
Can we iterate over all the floors and just say contains, and then if we find one that says true, then we can go to it?
Yeah, I was trying not to, but I'm trying to be lazy here. I don't think there's other option. So let's see. Let's try to do that. So this should be 3, right?
Yeah.
So would this work?
That would work.
I hope so, but I want to try it still.
Yes, of course.
Just not to do a whole bunch of coding just for the sake of it. All right, so going back.
So that first bit we did was right. That's good.
Exactly, that's what I was trying to check, not to have too many changes. Now, so we want to iterate through requests. But basically that means it will stop at every floor where it has a request. We don't have any way to optimize the system.
Right. So that, though for me though, I think this implementation is, it's not going to crash horribly, and I think we need another test case that will force us to fix this.
Yeah, but I think that's quite regular, right? To stop at each floor. It's just not optimized.
Yeah, and also it's going to do them all at once in the same tick. So that's I think we need another test case that's going to show that.
Yeah, exactly.
So anyway, we could do another commit.
So we refactored the... Another thing I'm worried about is this. I don't like this. So I'd look at this thing. It keeps appearing. It's already 3 times.
Yep.
So
this is a good point.
I don't know what I would create a helper method. I don't know, what would you do?
Yeah, absolutely. These 3 lines, 39 to 41, have come up several times. I think that would be a good candidate for tick and verify. If you take all 3 of those lines.
So these.
What happens to the extract method here? Yeah. The only thing I didn't like about that. Sorry, before you do that. Oh, I did it already.
No, I can go
so
back.
What I did. Yeah, so I'm thinking I didn't like the way that it's passing the lift system printer all the time. Can we make the lift system printer a data member of the test so it doesn't keep appearing everywhere? So like line 37, where we construct it, can we just change it to be
this one?
Yeah, move that to the class level.
There you go. And do you want to pass it or no?
I want to initialize it. I want to initialize it as well in the...
Okay, so let's move this as well.
Yeah, but I think before you can do that, you need to combine the declaration and assignment again.
I think it moves both of them.
I think you can move both of them, okay.
Or?
Oh, is it? Oh, no, now we've got the field. Yeah, great. Now we can use that instead everywhere. Yeah.
Okay. And the same here, right? I can remove this.
So now when you do the extract method on those 3 lines of code that we did before, the printer won't appear in the signature, which I think would be better.
Tick and verify, yeah. Another way how I do that is I would have extracted the methods, kept that parameter that you didn't like, and promote that to a field, and then inline it.
Of course, I probably was a little bit too opinionated there.
You're don't worry. No, it's fine. I think it's the same thing. It's the same result.
I might also move the tick and verify method to the bottom somewhere. But
of course.
Did we run the test just to sanity check as well?
I wanted to see what changed.
Right.
I typically put this in the top. How do you do that?
Sure. Top or bottom. I just like to keep the test together.
Because then I add the test and I need to keep moving the privates.
Yeah.
All right. Go back to the...
Well, hey.
Okay, another thing I didn't like was, it's just 2 times, but still.
No, you've got different arguments the other time.
Yeah, they're different arguments.
That's the same each time.
Yeah, I'm not yet worried about that, so I wouldn't do anything. Oh yeah, I remember now what I was a bit puzzled about. This one, that you have the private hash set, and here I have a list of integers. I think this could work, but I don't know if we did this on purpose, deliberate, or it was just a hack that we tried out.
So when I did the initial modeling, I modeled it as a list of integers. And now when we come to implement it a bit, we realize that it's actually better modeled as a set. But by doing it this way, we mean that we take a shallow copy. We're not using the same collection that came in from outside. So I think that's a good thing anyway. Which protects us from if when a collection comes into the constructor, you don't know who else has got a reference to it. By doing it, we're taking a shallow copy and we know that somebody else is not going to add elements to our collection. So I think that's not too bad. And so the only question is whether to change the constructor parameters to also be a set so that it's clear for the users of this class. But they don't need to know that we're using a set.
Yeah, I just wanted to make sure this is a deliberate thing. It's just something that remained like that.
Yeah, so I think this is okay.
All right, we could look at the next test, I guess.
Yeah, so we've got a weakness in the code that we know that it's going to answer. If we've got more than one requests, it's going to answer all of them. So I think we clearly need a test case with more than one request. So how about if we sketch this starting position where we've got requests for 2 different floors? So then the next position that we want to see is that it goes to the closest. It goes to the closest floor.
So it doesn't go to the last one; it goes to the first one, right?
Yeah, it goes to the one that it's closest to the current floor, I guess.
So here I have a request at second and at second and a third, let's say. That's also interesting. I think that the order matters here. Because if you do a test like that, that would be very different than if you do it like that.
Well, it's a set. It's not ordered when we store them.
Yeah, but you cycle it in order.
It's undefined actually which order the set's going to give them back to you in, I think. So we can see what happens. Can you? We only need to tick once, though, I think. So if you remove one of the lines of tick and verify. One tick should be enough to check that it's gone to the right. So can we try running this and see what we get? And we got a received file. Oh yes, see that? It's gone to the wrong one.
So it has gone to the third, but we want it to go to the second.
Yeah. So as before, I suggest you approve that because it's kind of a starting point. And then we can see when we actually change the code, what difference it makes. So
what's the logic? The logic is here because you still have one elevator. And what you're doing is that...
So it's the else clause here that needs to change. So we're just looping through all of the requests and moving to all of them. And we can't do all of them. So I think... we need to break after the first one. So can we just put a break statement after line 57 after line 57? I just want to break out of the for loop because we've got to one of the floors that we had a request for. It might be the wrong one, but we've got to one of them. And then we shouldn't go to the next one. So I think that might improve matters. Failed, that's good. It means what we changed actually did something.
So we still have the request.
Yeah, that looks actually correct. I think that matches the sketch. So it's gone to the second floor and it hasn't opened the doors yet. So that was right. So we could commit now because the output's looking like the sketch, but the implementation is still not absolutely correct, I think.
So what don't you like about the production code?
Implementation. Because there's no logic here actually to work out which is the closest floor.
It's just the first one.
It's just the first one that happens to come out of the set. So we go to.
That's why I'm saying let's try this. So if I do this, I guess it does have an order.
I'm guessing that the implementation has an order, but it doesn't appear to matter.
Okay, very interesting.
Not going to make it fail. So we maybe need to have constructed a more difficult scenario.
Yeah.
I'm trying to think because what if we had a few more floors?
So let's say we have 5 floors, ground floor and 4 or 5.
So I'm sketching here on my pad here. So how about this situation where we've got a request is that maybe we need even another one. There, let's have 3 requests, and then it's clearly one of them is closer than the other 2. So that we want to go down 1 floor instead of up 2 or up 3.
So the floor is.
Although I've introduced another
go down and
here.
go up. Yeah,
it has to go down instead of going up. It has to work out which is the closest in both directions.
Yeah.
So that might be a bigger step than we want.
I would just go up still, but try to have a request at, I don't know, 2nd and 4th. Does it help?
If we had a request for the 4th floor as well, since we've got 5 floors now.
So 2nd and 4th? Or do you want
the 5th floor? Put the 5th floor in as well. So we have to see, I mean, now it's only got a 1 in 3 chance of choosing the right one, maybe?
Yeah.
So it's going to fail because now we've got more floors. Oh.
No, it's going to fail because I didn't rename the test name.
Right.
Fulfilled 2 requests with 5 floors. Okay.
So the thing is, we had a test that's passing, but it's passing by chance. So we're putting in another test to try and see if we can flush out this the fact that our logic actually isn't correct.
So this is what it's doing.
It's done the right thing. So that's no good. Can we put the lift on the 5th floor and have it moving down?
So if we put it on the 5th floor.
And then change the request to 0 instead of 5.
And the request is at 0, like that, to 4 and 0.
Yeah. So now what we're hoping it will do is it should move down to the 4th floor.
So now in this situation, we are forced to introduce the concept of down.
Yeah, but at least...
Yep, it goes to
because
the ground
so
floor.
I think the set is by default it's returning them in this kind of sort order.
Exactly.
So that's why. But so now we're going to be forced to actually work out which is the closest floor. So I think we can cope.
Then the name of this test is. It doesn't matter, in fact, how many floors we have. We could simplify it because that's a bit confusing, right? So if I keep it like that, but fulfill 2 requests going down.
And then we can remove the request for the 4th floor. And we can put the lift on floor 3 because it's on floor 5, which doesn't exist.
Yeah. I need to delete this.
Yeah.
So it's got 3rd and it should go at 2nd.
Great. I would approve that because it's looking, we've set up the scenario. It's not correct. I haven't even got a sketch. I have to remember now that we want it to go to the 2nd floor instead of the 0th floor.
Yeah. So now let's go back to the production code.
Right. So here, we're going to need to introduce the concept of the closest floor. So instead of doing this dot floor equals request, could we assign closest floor to request? And then at the end of the for loop, assign this dot floor to closest floor.
So here, instead of request, we'd like to have something get closest.
No. That's not what I meant. Sorry. So I want to basically move that line to outside the for loop to the bottom.
That's what I was trying to do, yeah. But in a different way. Yeah, so how would you do that? Like just extract it?
No, I don't want to extract it.
But?
Can we rename request to closest floor? No, that wouldn't. No, that's no good either. I want a new variable called closest floor that's declared before the for loop. It doesn't need to be initialized there, I don't think.
Yeah.
Or maybe it does, actually. Actually, I'd like it to be able to be... Yeah, we know that it's not empty, so that we know that
it's minus 1.
Thank you. That's fine. So then in the body of the for loop, we can assign request to closest floor for equals request. And then I would just move the line 59 down to after the for loop.
Oh,
and
okay.
then
I get
change request to closest floor.
Oh, okay. So you just wanted to introduce a variable in between those two. Okay.
Yeah. So now we have this concept of first closest floor, and this for loop bit here is going to turn into a method. So I can extract a method from line 56 to 60. Include the final bracket as well. There. Get a closest floor. That's what I want. Right. So now I can inline that call. So that part is now looking like it has to. Now we just need to get closest floor to actually do the right thing.
Well, let's say I wanted to do this, but in a different fashion. Again, that's fine.
I'm being a very fussy navigator.
No, that's fine. It's fine for me because I learn new ways, so I'm happy with that.
So now this method, if we were feeling worried about this method, we could go and write some ordinary unit tests for it. Or we could just see if we can come up with something that works. So I'm thinking what I want to do is to create a list of, I've got a set that contains all the floors I've requested. So I should be able to transform that to a list of absolute difference between the current floor and the floor number in the set. I effectively want to do a map over the set of requests. In Java, that's you need to do collections. So if you take the request and then stream it,
that's gonna be hard on me.
Stream?
Haven't done that in a while.
Dots. Then we should have map. And then we want a function, which is going to be a lambda. So we can take the variable name could be R for request. So you want R, and then you want one of those arrow things. And then we want math.abs.
So that's how we want to make this. Okay.
Yeah, and then we've got self.floor minus R. This floor.
Yeah.
Sorry.
You're doing Python. Yeah. R.
Yeah. And just R.
R is
So we might want to declare that R is an integer. I think that's why it's red there at the start.
Oh yes, of course.
Yeah. Okay, and then we need a dot here.
Nope. Integer, right?
Yeah, integer. Oh, maybe it needs to be a.
Nope.
No.
I used to doing that, but that's not Java.
Let's try int again with a small I.
Int is good.
It should be an int. Is it the arrow that's wrong? Is instead of an equals, is it just a dash?
No, it says
it is a double arrow. So at the end here, we definitely need another dot because we have to collect it, but it seems unhappy about my lambda.
Yeah, because it says expression expected, and this isn't an expression. It's an unexpected token. So if I...
Right, so now that should be the identity function. It didn't like that either. So let me Java syntax.
That's why I said this is going to hurt me, because Java and expressions, I never like them, I never use them. I think it's easier to use something else, like Groovy.
Oh, come on. This is built into the syntax of Java, and Java is such a universal language. Everybody knows Java, except for the syntax for the new stuff.
Exactly.
It is a single dash and then an arrow, I believe. Looking at the examples I'm looking at.
So then
And maybe then you don't need the int at the start.
Yeah, because it looks okay.
Yeah, there we go. Right. So that was the problem. So now we've mapped it to that. So then we need to collect it. So collect, and then collections as list, I think is, or collect. There's some kind of list collector at the end. Collectors to list. It's an argument to the collect method. Sorry.
I'm totally.
Collectors with a big C, which is a class.
Yeah.
To list. They're the first one there.
Let's see. The one.
Yep. So that's we could assign to floor distances.
Floor distances. Okay, but that's what is this? Is a collection, right?
Yeah, just write floor distances and let IntelliJ work out for you what type it should be. Yeah, and in fact, I've just realized though we need to store as well what the original floor was. Because now I've just got the difference. We need so I'm thinking in Python, of course. I would just have a tuple there instead of returning that. I would do a tuple with both the R and that expression.
I guess you can do it here as well. Well, but you don't collect that just this. You collect also the floor. And it should be something like this, right?
Yeah, at least integer. That's what I'm looking for.
So here, maybe would it be this?
No, I don't think so. Oh, no, I don't think there. If you do it inside the
collector, I guess.
No, next to the math.abs.
Yes.
So if you
so
do
you mean this?
R, no, not this, just R, comma. And then you might need some extra brackets.
No, this looks fine. Well, like this, because this is an expression, right? But it's not.
I would have put the bracket. I'm thinking Python as usual.
Yeah.
To make it tuple, put the brackets so that you're enclosing the R and the math.abs thing as a tuple of 2 elements.
Okay. No.
How do you construct a tuple in I mean, this is not the Java-ish way of doing it, clearly.
I guess so. But we can force it. Oh, come on. No. Let's make it work. So, if you want to map 2 things, now it's complaining about this.
I've got a list with list of tuples is what I'm looking for.
Of course, this doesn't do anything. So can't it be here into collectors? Because that's a change that you do, and then when you collect, you collect to list. So what can I do here? Look, I can collect a stream now, a supplier, collection factory. Oh boy.
Okay, Addy, we are getting nowhere, really, honestly.
Yep. Okay,
I don't clearly know the Java streams syntax well enough, so let's not do this. We've got a loop for our requests. Let's just do this the pedestrian way. And on line 66, at the moment, we've got closest for equals request. Let's change this so that instead of having a break there, we're doing if the floor is minus request is less than. So
what do you want to do? Is less than the floor distance?
Close this floor. We have to start with the closest floor here, minus request. Is that right? So I'm basically saying then we assign closest floor to request.
So what's with this then?
So we delete that.
Okay.
As a failed experiment. I was going to sort it and then take the first one, but that's clearly...
But what if we do that?
Well, the thing is, we've lost the information about which floor it was.
Okay. Yeah. Okay.
So we have got a list of all the absolute differences, but we can't work out which floor it was that was the closest. And we need some maths.abs here, and we need to make sure that I haven't done something really stupid. So we can remove line 64 as well.
Okay.
So I'm basically trying to work out, is the absolute difference between this floor and the request less than the...
So closest, I don't
minus
know.
this. Right.
So this is -1. Is this right?
No, that's not right. So we need to initialize it the first time around the loop.
We need to initialize in the loop, but with what?
Except we have to initialize it outside the loop.
No, I think we need to
without a
Is it do that? The closest floor is the floor.
No. Oh. The algorithm I'm after here is basically to, each time you go around, you initialize the closest floor to something random from the list, and then each time you go around the loop, you compare it. Well, am I closer to the current loop variable, or am I closer to the closest floor?
Mm-hmm.
And if I'm closer to the current loop variable, I reassign closest floor.
Mm-hmm. Yeah. So
am I making any sense?
Yeah, you are, but I don't know. I might be tired.
So we definitely need math.abs here as well.
Maybe that's a sign we need a break. So
yeah,
this is the floor. The current floor I am in minus the request. So let's say I'm at the, what was it, the third floor. The request is at good 0, so that would be 3, should be smallest than closest floor.
It should be this dot floor minus closest floor there. On the other side of the less than.
Mm-hmm.
And then you need math. Then both of them need to be math.abs.
Both of them, yeah.
No, bracket after the request.
Oh yeah, sorry. But now, is this right?
That's not right.
That's not right. So what's the closest floor? How do I define it?
So we need a starting value for this. Mm-hmm. And it needs to be a value that is in the list of requests.
Mm-hmm.
Or a value that is a very, very long way away. So int.max, integer.max value.
Okay.
That's, yeah.
Yeah, because it's quite difficult to have, I don't know, what's that?
There's not going to be a 64, floor that's
64 bits. No, it's not 64, it's 32 bits, so yeah. 60,000 floors.
We might want to actually run the test now and see what we just did.
Live system test. Failed.
Failed, so we did something. That's good. Ooh, that's looking better.
So it goes, yeah, it goes to the second floor, and it has requested. Yeah, looks great. Now I'm curious, if you continue, would it go to the ground floor or not?
That's good. We could try that. We could, prove that. We could just add a couple more of ticks and see that it opens the doors correctly and does all the right things. Yeah, add another one as well.
So if I do, is this enough?
Do another one, because it needs to open the doors. Oh, we haven't implemented anything that's going to close the doors again before it moves.
So it's going to go with open doors. That's fun.
Yeah.
Where was I? I moved back. So you say, sorry, you said add another one, so I have 3 here?
Yeah.
Okay.
And now I think we can see it moving with the doors open. So that'll be interesting.
Yeah, not very safe.
There, so open the doors and carried on moving with the doors open.
Yeah.
Right. So approve that. And we although I don't know, we might wanted to have done a commit actually before we
Yeah, I'll do that.
So just remove that last tick and verify. Run the test again, because we effectively just added another test case.
Okay. Do this. Yeah. This works well. Now we should be on green. Okay, so let's debrief about what we've done until now. So how was it? For me it was a bit challenging with Java, since I keep mixing it with other languages. But it's nice, you know, it's a bit struggling, but it's also, it shows that I'm learning. That's fine, I'm happy with that. Then I think I've done approval tests, but not that much. I mean, not in this situation. I've done it only with a few tests because there were big legacy code, so the situation that you mentioned. So I haven't done in this short iteration, short cycle that much. And that felt interesting. But at the one moment you mentioned that for that small method, I guess the one from that we extracted from Lyft, we could have added a unit test. So the approval tests, I guess in this case, are like scenarios, and then you have unit tests that are smaller grained, right?
Right. So I see it that way. I see if you look at the BDD process, you start with these kind of user-facing scenarios that you discuss with in the 3 Amigos and all that, and the standard way of doing that is in Cucumber or Gherkin syntax. But if you instead formulate those scenarios as a sketch, you can use them as a basis for approval tests, and then you can drive the functionality out in the using that as your kind of guiding test. But that doesn't stop you from dropping down to writing unit tests when you want to. But that doesn't necessarily happen that often. We could have dropped down to unit tests here, but we could have just kept going with the approval tests.
Yeah, it was just that part where the logic seemed a bit more complicated, and then maybe for not getting stuck, I think that could work in some situations, maybe, right?
Yeah, I mean, we got a bit stuck there, but it was because we're neither of us that good with the Java syntax more than the actual problem being difficult. But I'm glad to hear that you thought that there was short feedback loops here, because I think that's true. Every time we can approve stuff that isn't finally matching our sketch scenario, and then you've got an opportunity to refactor, or at least you can see exactly what effect your changes has on the printed output.
Yeah, and I think what was interesting that I didn't do before was to have these incremental approvals. So incrementally approve step by step what I'm doing, but still I know I'm not done, but I'm just adding up.
Yeah, so it means that you can still work in very small steps, even though you've actually got quite a scenario, which is quite a big test. It's going to take several pieces of code before it'll pass, depending on how big the scenario is, of course. So you get the effect of still being able to take small steps, even though you've got a big test.
Yeah, I think it was very useful for me to not to go into to do. I think we've done more or less strong style pairing or you've done more or less strong style pairing. In some situations we were more like classical pairing approach, but I think most of it was strong style, and that helped me not figuring out too many things, and helping me in some moments to just listen and do that, and was very helpful.
Yeah, so I've been doing more mob programming lately, so I'm used to the strong style actually. And I don't have the keyboard, so it's quite natural for me to try and take over and tell you what to do. And I think there were a couple of moments there where I felt I was a little bit too opinionated, and you were going to do what I was going to tell you to do in a different way, and I could have backed off a bit there. So
yeah, but that's strong style. I mean, you tell the coder what to do, the driver, right?
Right, you do, but at some level, the driver does have the tools at their fingertips. So when you give the high-level command or instruction, I'd like you to extract a method for that. I maybe shouldn't have been quite so opinionated about how you did that and exactly how you got that. Actually, it was a field I wanted you to extract.
So even with strong style, you're saying that you can have these two approaches, like saying what you want to do, but also saying how you want them to be done, and you need to adjust depending on what's going on, right?
Yeah, so I see strong style as you start with a high-level instruction, extract a field for me, and then if the driver knows what to do, they just get on with it. But if the driver doesn't know what to do, then you drop down and you start giving them more detailed instructions, like I want you to put the cursor there, and I want you to press this key combination, and it's you have to put your instructions at the level the driver will cope with. And I think I was dropping down to the no, do it like this a little bit too easily, and I should have been perhaps giving you more high-level instructions. But that's the kind of thing you learn as you get to know each other and the strengths of the person you're working with, and how much in detail to give.
So about the kata, for me, it was interesting. I think that the idea to have it as a starter kit like that, to have everything to help you start, I think that's useful. Maybe especially for beginners, to say, what am I doing now? How should I solve this? And I think it's kind of easy to go on the wrong path if you don't have this starter, or it's also easy just to give up and say, it's too difficult, I don't know what to do here. But also from another point of view of not losing time when you want to really do something. I think from these three arguments, this approach to having a starter kit is very useful.
So particularly if you're trying out this approval testing approach, that if you haven't done it before, it's nice to have some printer already there, so you don't have to worry about writing that part. But it comes at the cost of you have to read and understand the code to some extent. And you might discover that some of the design decisions I've made weren't very good, like having a list of requests instead of a set, or having final variables. I'm going to change that. Yeah. But I'm glad you like the idea of having a starter kit.
I think I tried that before with other things, like when I was teaching C++ workshops, you need to have a starter kit because nothing ever works in a workshop in C++. The compiler doesn't work, it doesn't work with the system. So I think that's where I learned in the hard way that you need a starter kit for more difficult structures. But it's even helpful, for lighter weight things. And also with this, you mentioned the code. I think that there are some decisions, and it's normal from the beginning not to make the best ones. I mean, you can also iterate, and that's a feedback. I mean, what we've done now, it's a feedback that, it could be improved, but nothing's perfect, right?
Yeah, and it's a starting point, and you're going to need to refactor the existing code, probably. And at some point, if you continue with this exercise, you realize that you need probably another printer or to improve this printer so that you can include more information. So this is just a starting point to get you going.
Yeah, it gives a direction, that's for sure. Yeah, I think as we looked at the time really passed fast. So that means at least for me, I enjoyed it a lot, and I think that's a good sign when you look out the window and say, oh, what's the clock? Or what's the time now? Wow, amazing.
Yeah, where did the day go? Yeah. No, it was good. It was good. We got into some flow and we wrote some code, and the code we've written is it's okay, I think. And of course, the code's going to be on GitHub now. You're going to push this presumably to a branch somewhere, so that people can have a look and see what we actually did.
Okay. Anything else about our session? Final words?
Final words. If you've watched this far, all this code is on GitHub. Do have a look at it, try it out, and you might be better at Java than we are and be able to actually get a bit further with the exercise. And if you do, maybe you'll tweet about it, encourage your friends to try it out. Maybe you'll learn something about approval testing and about test-driven development. And have fun with the code.
Yeah, that's a very nice ending.